Okay, so first tell me what is the characteristics of a linear data structure, because we already have learned about array and linked list and both of them are linear data structure. So first tell me which similarities or what are the similarities that we have found between array and linked list and what is the difference between them? Array and linked list both are linear data structures, right? So what are the
Yes.
similarities between these two data structure? One similarity is here there should be some relationship between the data elements, right? And what is the major difference? The difference is, suppose if it's array, then we have to use a contiguous memory location. Suppose we have 5 data elements, 5, 10, 15, 20 and 25. So how these 5 data elements will be stored in the array? At first we have to declare an array. Without mentioning the array size, we cannot insert the data item. So suppose the size of the array is 5, that means we can insert 5 data elements. And if it is the first memory location, and if we are inserting the first data item, that is 5, then the next data item will be stored where? In which memory location? Obviously in memory location 2, right? That is the characteristics of array. But what about linked list? In linked list, we don't need to maintain the continuous memory location. Suppose the first data item 5 can be stored in position 1, then we can store 16 where? In location 4 or 5 when you are in the list. So if stack is also linear data structure, then what do you think? How we can actually insert the same data elements 5, 10, 15, 20, 25 in a stack? Stack is a linear data structure, so obviously there will be some relationship between the data elements and between the data elements and the memory locations, right? So if I say that this is our stack, which will act like a container, okay, and this is the top end which will be open. It will be open for insertion and deletion. We can insert any data item at the top of the stack and we can remove any data item from this stack. So one difference between array, linked list and stack is here the size is not fixed. At the time of declaration, actually we don't need to mention its size. Is that clear? The size of the array is fixed. Before inserting any data item, we have to mention what is the size of, what is the capacity of that array. But in stack, it's not fixed, and the size of the stack depends on how many numbers actually we want to insert, how many data items we want to insert. So initially, the stack is empty, right? Initially, this stack is empty. Now, if we insert the first data item 5, at that time, now the stack has 1 data element. But when the stack was empty at that time, can you say that the operation is empty equals to 1? So now what is this operation is empty? This is an operation that can be performed on stack, okay? And this operation will always return a Boolean value. The output of this function can be 0 or 1. So in this function, actually, we need to check whether the stack is empty or not, okay? So initially, when the stack doesn't have any data item, what will be the value of this function is empty?
0.
The value will be 1 because the statement, this operation is true. The function name is empty. That means
Yes, ma'am.
stack is empty or full. And here we can see that the stack is empty, so the output of this operation will be 1. And when the stack is empty, and here we use one pointer called top, because this point will be used for inserting or deleting any data item from the position from the stack. So when the stack is empty, can we say that the value of top is 0? This stack doesn't have any element, right? That's why the value of top is 0, which means that there is no data element stored here. And when we can use the value 0, if we are using unit-based indexing. Now, what is unit-based indexing? Suppose we are inserting some data item here. If first the data item is 5, so after inserting it, we can say that it has stored in the memory location 1. When we are inserting the data item 5, and this is the first data item of the stack, And after inserting it, now the value of top will be changed because now this stack has one data element and its position is 1, right? So now if we want to store the second data element, that is 10, where we can insert it, this is stack, and all the operations should be done where? Only at this end. So we can insert the data item at the top of the stack. So after inserting the second data item, now the top value will be changed again. After inserting two data items, 5 and 10, now the stack has how many data elements? Two data elements, and the topmost data item is 10 and its position is 2. And this top pointer, it will always contain the position of the topmost element. And now if we insert another data item, it will be stored where? In memory location 3, and that time the value of top will be again changed. So look at this stack, how we are actually inserting the data item only at this top, only at the top, right? And stack, this insertion operation is called push. What is push operation? It's just the other name of insertion. In stack, if we want to perform an insertion operation, that function name should be push. Okay, now suppose we want to insert the data item 20. So where we'll insert it? Obviously at the top of stack. So here we can insert 20. Okay, and after inserting it, what will be the value of top? 4. Okay. So this is how we can change the capacity, or we can change the value of top. So here the size of stack is not fixed. So when this stack has only two data elements, at that time you can say that the capacity of stack is 2, or it has only two data elements, or if we can simply write the pointer top, because from this value we'll get to know how many data elements are stored here, because we are using some continuous memory location. So that is push operation. Now what will happen if we want to remove some data item? Stack is called last in first out data structure. Why it is called last in first out data structure? Just think about a pile of books. Suppose this is a rack, and if we want to insert a book, it will be inserted here. After that, we can insert the second book here, and then the third book will insert here, right? And we can insert the fourth book at the top. This is the process of inserting the data item. So what about deletion? We cannot just simply remove any data item from the middle of the stack. At first, we will remove the topmost data element, and after removing it, now it will become the topmost data element, then we can remove it. After that, these elements will be removed, then the last one. So here, can I say that the element that was inserted first, it will be the last element to be removed? Can I say that?
Yes, ma'am.
This
Yes, ma'am.
was inserted first, right? We inserted the element first, but we are now removing it at the last. That's why stack is called last in first out data structure. So how we can perform a deletion operation? The deletion operation will be denoted as pop, right? And if I just write pop, and here there is no argument written inside the parentheses. There is no argument here, right? So it will always denote to the first data element, I mean the topmost data element. In stack, the pop operation or deletion will be done from the top. That's why we don't need to actually write the argument here, or if you want, you can write it. Okay, so when here the parenthesis is empty, it will indicate to the removal of the topmost data element. So after removing 20, now how many data items? The stack has 3 data items, and again the value of top will be changed. It will be decreased by 1. Now the top value is 3. And after that, if we want to delete another data item, that is 15, then you can easily delete it from the position 3. Okay, so what will happen if we want to delete 5? So after deleting 15, now the stack has how many data elements? 2 data elements, and we want to delete 5. So at that time, at first delete the topmost elements 10, and then we can delete 5. Is that clear?
Yes, ma'am.
Yes, ma'am.
So how we can define stack? This is a linear data structure, or we can say that stack is a list of elements where the elements can be inserted or deleted only at the top. And another important characteristic of stack is the elements are removed in the reverse order, right? The elements will be removed in the reverse order in which they were actually inserted. So these are two characteristics of stack. So now I told you that the size of the array is not fixed. So if we don't know what is the capacity of that stack, how we can, represent the stack in computer memory. We know that computer has some memory for storing the data element. Just think about array and linked list. It has some fixed size. It has some capacity, right? And then you can store the data elements in the memory. Can I clean the board?
Yes, ma'am.
Okay. So in array, how we can represent it in computer memory? At first, we need to declare the array variable, right? And then we have to mention the size of the array. So integer A5 is the name of the array. And if the data type is integer, that means it will take all the whole numbers. It will take the whole numbers. And how many data elements can be stored here? Only 5 data elements. So what about stack? Can we store different types of data in one stack? In array, if the data type is integer, so all the data should be integer type. Suppose 2, 4, 6, 8, 10. We cannot store A, B or any other character here. What about stack? Suppose at first we inserted the data item, the operation was push 10. So after that, can we insert the data item A? Is that possible? After that, can we insert A? It's not possible. Okay, so in stack, it always stores similar type of data. So if we are storing numerical data here, so all the data should be of integer type, and here we cannot store float numbers also because the first data is an integer. So the next data can be 15, but not A or not 1.0 or any other float or character data. Okay, so I was actually talking about the memory representation. For array, if we want to store it in computer memory, at first we need to declare it. And at the time of declaration, if the size is 5, then how many space it will allocate?
5.
Why 5? We know that
Oh,
yeah,
6,
it will
6.
take 4
Now,
bytes from the computer memory. So total it will occupy how many bytes? 20 bytes. It will occupy 20 bytes. Look at this here. The name of the array is A0. Sorry, A. So the first element is A0, then A1, A2, A3, and A4. So what is the value of A0? 2, right? But another thing is, when we are representing it at that time, we have used unit-based indexing. But for referring here, for referring the data element, individual data element, we are using zero-based indexing. So can you use 0 here? Suppose 0, 1, 2, 3, then 4. Both zero-based indexing and one-based indexing are correct. But why we're not using zero-based indexing here? Because at that time, if we want to calculate the number of elements, the equation will be upper bound minus lower bound, then again plus 1, isn't it? What is the disadvantage of using zero-based indexing? At first, we have to take the value of upper bound, then minus lower bound plus 1. And here the upper bound is 4, the lower bound is 0 plus 1. So there are total 5 elements. But in unit-based indexing, we don't need to add 1. Right? So, but both are correct. So here A0 equals to 2, A1 equals to 4, then A2 equals to 6, 8, and 10. Right? So we can say that before storing the data item in computer memory, we have to declare it. We have to mention the size of that array. But what about stack? How we can represent or how we can store stack in computer memory? So for stack, there are two types of representation. One is called array representation and another is called linked list representation. Okay. So if we want to represent stack as array, at that time we have to mention the size. Okay. Suppose the name of the stack is stack, and if we want to insert 5 data elements, we have to mention it here. So integer stack 5. Usually array doesn't have any fixed capacity. The array, I mean stack size is not fixed. It depends on how many elements we are actually inserting here. But when we want to store the elements, or when we are actually representing the stack in computer memory, at that time we have to use any one of them. We have to use array or linked list representation. Okay, so in array representation, we can just declare the variable just like we declare it in array. Okay, so here the data type is integer and stack is the name of stack and 5 is the capacity of this stack. So here we can store the data 10, 15, 20, 30, 35, maximum 5 data elements. So that is the array representation of stack. So another one is linked list. What is linked list? It's different from array, right? How we can represent linked list?
You also need the pointer.
Yeah, by means of pointer. And another thing is in linked list, the node will be divided into two parts, right? Suppose we want to insert the data item 10, 20, and 30. So how many data items it has? 3 data items, right? And each data item will be considered as a node, and each node has how many fields? 2 fields. This is the data field which will contain the data, and this is the next pointer field. Okay. And suppose the memory location of 10 is 1, for 20 it's 2, for 30 it's 3. Okay. And from this head pointer, know which one is the first data element. So if head equals to 1, so 10 is the first data element, right? And here if we store the value 2, that means 20 is the second data element. Okay, and then here the address of the third data element is 3, which means 30 is the third data element. Okay, and there are no other data elements here. So if we want to stack, suppose this is our stack, and we'll insert how many data items? Just these 3 data items, but we'll follow the linked list representation, which means that now here we have to store 2 fields for each of the data item. So how we can do it? Suppose initially top equals to 0. Top equals to 0. Okay. And so how we can insert the data item? And then one characteristic of stack is we always retrieve the first data item in the last, isn't it? The first data item will be removed first. So here, look at this. Which one is the first data element? 10. 20 is the second data element, and 30 is the last data element. So if we store 10 first, then what will happen? Suppose at first we inserted 10, and then 20, and then 30. And at the time of removing a data item, at that time we'll first remove 30, then 20, then 10, which is the reverse order of the previous linked list. So you cannot do it. So in the stack, how we'll insert the data item from the linked list? We'll insert the last data item first. So if we insert 30 here, okay, and what is the value of top? 0.
0.
Isn't it? So what is the position of 3?
1.
No, the position of 3 is 3. Look at the linked list. The address of 30 is 3. So if we write it here, and here we can use another pointer which is called new node. Or you can call it in by any other name. So this is new node. So initially, or look at this, when we are actually inserting the data item 30, at that time, what is the value of top? 0, which means no other element are inserted here. So 30 is the first data element, and we can simply write 0 here. So you can make it 0. What is the value of what we can write here in this pointer? We can write 0, which means that we are inserting 30 first. That is our first data item in this stack. Okay, so after inserting 30 and its position is 3, now we can change the value of top. What is the value of top? 3, because we inserted this data item here. So after that, which data will be stored? Obviously 20.
20.
20.
20 will be stored, right? And what is the position of 20 in the linked list? The position of 20 is 2. So after inserting it, now the new value of top will be 2, because 20 is the topmost element now. And before inserting 20, the stack has another data item 30 in which position? In position 3. So here the new node value will be 3. Okay, and now the last node is 10. If we insert it here and its position is 1, so after inserting 10, now the new value of top will be 1, right? And which one is the previous data item of 20? The previous data item of 20 is, sorry, the previous data item of 10 is 20 and its position is 2, so we'll write it here. So now look at this. Can we create a relationship here? If 10 is our topmost data element and its pointer field addresses the next data element in which position? In position 2. That means 20 is the next data element, and after that from this pointer field we can say that 30 is the third data element and it is actually the last element of the stack. Now if we retrieve the data element from the stack, we'll first remove 10. So you can write it here. After that we'll remove 20, and then lastly we will remove 30. So this is the linked list representation of stack. Is that clear?
Yes, ma'am.
Okay, I'm repeating the concept of linked list representation again. The previous one was array representation, right? And we just did the same thing, or we just followed the same way we did for, array representation. How many things we need to have for array declaration? 3 things. One is which type of data we want to insert, right? The data type. Then the name of the array, which will be used as the name of array variable, and then the size of the array. Right? And when you are representing the stack as an array, exactly we need to know those 3 things. The name of the stack, the data type, and how many data items we want to insert. But what about this linked list, representation? In linked list representation, each node will be divided into 2 parts, right? So we have to follow the same way when you are inserting the data element in the stack. So if the first data element in the linked list is 10, it will be stored
At the top.
when you can insert it. If the first data element of, sorry?
We have to begin from the end.
Yeah, we have to begin from the end. Okay, and another thing, suppose we don't know about this linked list. We just have this stack. Okay, suppose we just have a stack and we want to, or we have 5 data elements, 15, 25, 35. Okay, and suppose our first data element is 15, which is stored in memory location 1, and the second data item is 25, and the third data item is 35. Sorry. So now how we can remove them, or how we can represent these 3 nodes in linked list. These are our 3 data items, 15, 25, 35, and the value of top is 3. How we can represent them in the list? Obviously 35 will be removed first. So 35 will be the first data element, and then 25, after that 15.
15.
But here we only know the content of one field. What about the other field? Here the position of 35 is 3, the position of 25 is 2, and the position of 15 is 1. And from this top pointer, we know that the First data element is 35. So here head equals to, what will be the value of head?
3.
3. Very good.
3.
3.
Head equals to 3. Right? So now here we can create a link, that is 2. After that,
1.
That should be 1.
yes, 1.
Yes.
This is 1. So in
0.
the
0.
same way, we can write it here. When we are inserting the element 15, at that time the stack was empty. Okay. After that, when we are inserting 25, at that time the stack has only one data element in position 1. Right? And when we are inserting 35, at that time the topmost element was 25 in position 2. So that is the stack. Clear?
Yes, ma'am.
So this is the linked list representation of stack. Okay, so these are the two ways for representing stack. And I think the time is almost up, right? So in our next class, we'll discuss about some application of stack.
Okay, ma'am.
Sure, ma'am.
Let me just open the attendance sheet.